Have you ever wondered what does it take to build a custom rifle action? I'm here in Post Falls, Idaho at Bat Machine. We're going to answer that question in this video. Okay, Bruce, I had an idea. What would you think of not only giving us a tour of the factory, but showing kind of the start to finish process of building one of your custom actions?
Yeah, that'd be good. I'd like to do that.
Let's do it.
Okay.
So Bruce, what do we have here?
We have the receiver blanks and the finished product.
Wow.
And all the operations in between. So this is just the bar steel, cut off 12-foot bar, 17.4 stainless steel.
And 17.4 stainless has a bit better properties compared to barrel steel, does it, for
It
rifle
has a
actions?
higher degree of toughness and depends on the heat treat, but yeah, we prefer it. And then after it's cut off, it goes to heat treat, gets hardened, and...
Now, I know some of you just noticed that this is larger diameter than this one, and that's because this is a different variant?
Yeah.
Yeah.
This size of material is needed because we make this model receiver with a 40 MOA rail, integral, so that requires bigger material.
And don't worry, we're going to show all of this in detail. Wanted to give you guys a high-level kind of overview of the process from start to finish.
Next thing that happens is that heat-treated blank gets a hole popped all the way through it so that we can do the next operation of wire EDM.
And facing on both
Yep.
ends?
Faced at the same time, within 10th thou of finished overall length. This one here has had the wire EDM work done. Bore and raceways cut in one operation. After that's done, the receiver is put on a mandrel, ID, OD trued up to each other, and then threaded.
And those threads are critical because when you're building a custom rifle, that's kind of the datum point.
Right.
The bore has to be concentric with that, and that's the critical element
Exactly.
of the whole thing.
Yeah, that datum is where all the rest of the operations of the receiver happen, and it's critical for the accuracy of the finished product.
And this is where a custom rifle action can really stand above something like a factory mass-produced variety. Is they would have something like a tap, wouldn't they? And just mass-produce these or something like that?
And order of operations is different as well. The order of operations we use to create this, to get to this stage, is all designed around to make it as accurate as possible, to do the most extremely accurate job we can do. There's faster ways of doing it, faster operations, orders of operations that could be done faster, but it's not necessarily going to give you the repeatable results that you're trying to get every receiver for year after year. So this one is that receiver in the next operation, Tang cut, bolt handle, notch, cocking piece slot, and final operation is between centers. All these operations are completed. Engraving, everything is completed in this operation.
And this one has been through finishing as well? Like
this
polishing?
one has been through the polishing department.
Wow. It's a beautiful piece of artwork. And let's talk about how much material is removed. When we're talking about this round bar
So that
here,
one is 9 pounds.
Yep.
That's 1 pound, 3 ounces.
So that's a lot of, it seems like that's a lot of waste. How do you think about that?
It's the only way to do it properly.
Yeah?
If you want extreme accuracy in your receiver and you want integral rails and all the things that we feel are the most important to make a truly trouble-free, everything done to the best way it can be done. That's the way you got to do it.
So if you're wondering why custom actions cost quite a bit more than factory mass-produced actions, that would be one of the reasons, huh?
Yeah, for sure. Yeah.
Okay, so that's the high-level process. Why don't we next walk through the different machining stations for all of these processes and go into more detail?
Yeah.
So here we are at the heat treating station.
Yeah, so all the blanks get heat treated, like I said before we start machining. And that's to achieve the hardness to make the receiver safe and long lasting. A load of material we generally get, depending on diameter, we'll generally get 15 to 20 blanks in there, and then they have to soak for an hour per inch. So you have to add up how much you got in there. So generally it takes about an 8-hour shift to heat treat a full batch.
So you're bringing all of those steel blanks up to a uniform temperature in the oven.
Yep.
And then you're gonna, sometimes when you're hardening, you would oil quench.
Right.
Or even water quench or whatever the material is.
17.4 stainless is kind of a weird material. 17.4, 15.5. They're precipitation hardening. So the transformation that takes place inside the steel molecules does not require an oil quench and a subsequent temper. All the transformation takes place at the temperature that you run it up to. And then it has to be there actually at a certain amount of time for that transformation to happen. And then it's just air cooled.
Yep.
So, yeah.
So we alter the material properties and then it's on to machining.
Exactly.
All right, let's do that next.
Okay.
So tell us about this machine.
So this is a Mazak HCN 4000, full 4th axis on the pallets. It is as I said, pallet machine. So this is actually the side where the parts are loaded. The other side behind that door is where the machining actually takes place. So when we're doing these blanks to take them from heat treat to getting ready for wire, we talked about over there, we face the ends off and drill the hole. Obviously a different fixture than what's in there at the moment, but we face them off, drill the hole, and take them out and head to the wire machine.
Yeah, and the whole purpose of that hole is to get that wire through there.
The only reason for that hole is just to get the wire through there. It doesn't have to be precise, but what does have to be precise is the overall length and the squareness of that. Because the wire EDM, the wire guides are only 5/1000ths off each end. So if there's any variation in the squareness of it, the guides can hit and the flushing decreases efficiency. So
let's see the EDM machine.
Okay, let's do it.
So here we are at one of, is it 2 EDM machines that you got here?
2 wire EDM machines.
And tell us, before we get into the process, tell us a little bit about the machine itself.
So wire EDM uses a very small wire. In this case, we're using a 10,000ths diameter wire. I don't even know if you can see that in the camera.
It's tiny. It's tiny.
And it's fed at a rate depending on how much amperage is being put to the wire. Obviously, the more amperage is put to the wire, the quicker the wire can burn in two.
Yeah.
And then that's not really part of your plan.
Yeah, right.
It's like having your bandsaw blade break.
Yep.
It's actually a very good analogy. It's basically an electrical bandsaw.
Interesting.
The wire's charged with electricity and it burns away minute particles of steel. And as it's doing that, there's a flushing from the top and bottom of the wire that flushes the chips away.
Deionized water.
Deionized water, yep. And without the water flushing the chips away, the process would be impossible. It just flat wouldn't work.
And let's talk about the motion of the machine here. We've got linear motors.
So this particular wire machine is a Sodic, and it uses linear motors. There's no ball screws, no motor as such as like a conventional motor. It's just a flat motor. It's an electrical field that controls the movement, along with glass scales for positioning that it's referencing for its position. So, and it reads to the, let's see, what do we got? 5 places behind the decimal. Extremely accurate machines, extremely accurate.
And this whole tank and all of the work can move with the linear motors guiding it precisely. And then there's the top and the bottom guides for the wire as well. Yeah.
And then the upper guide actually has another axis. So you've got X, Y, and then you have U and V on the upper head that allows you to do tapers.
Yeah.
Which is utilized in these longer actions to actually help us create a really straight hole.
Gotcha.
So
that's the machine and how the machine works roughly. Let's talk about
Yep.
what's happening with our work.
So, talked about the hole getting put through there, and that's just to get the wire through there, to get your electrical bandsaw. And it's going to cut out the shape of the raceway. Let's see if I got, I don't think it's different size.
So this is your waste piece here.
This is waste, yeah.
Yeah.
And it comes out as one chunk.
Wow.
It just basically has the wire gap between it. So recycle these because they're stainless and get money for them.
Yep. And what's amazing to me about this is that you've got something that's shiny with a great surface finish in there, and it's going to go, I presume, through polish or whatever.
Yeah, actually we don't do a lot of polish because the surface finish is very good. It goes through the polishing machine, but there's not a lot of really polishing that happens in there. The bore's pretty close to the way it comes out of the machine.
Wow.
So
truly an amazing process.
Yeah.
It's hard to believe that it works as well as it does.
Right. It's come a long way since wire EDM was invented, that's for sure.
So now we've got our bore and raceway. Now, next we need to true up the...
Now we need to true the OD to the bore. Yep.
Okay, so onto another CNC machine?
Yep.
Okay.
So this is the machine we use to true the OD to the ID.
Tell me about the machine. How many axis? What do you...
So this is a fairly simple one. So this is 3-axis XYZ, live milling, and C-axis on the lathe spindle. And then just standard programmable tailstock on the back end. Fairly basic machine in today's world. It's actually the only machine we have as far as lathes, CNC lathes, that actually has a tailstock. All the rest of our lathes have sub-spindles in them instead. So
Gotcha.
this is the machine that works the best for truing the OD to the ID. So basically it's a very simple operation. It just goes, mandrel goes in the hole, center goes in the other end, and yeah, gets trued up. And then after a batch of those is done, then a chuck is put on, and the chuck jaws are bored true each time that happens, and then the front end is threaded. But before he threads each action, they are indicated. We actually, I mean, the ideal setup would be like to have the chuck jaws right up front, right, for rigidity. I mean, that's always, rigidity is paramount to accuracy. But we actually leave it out a couple inches so that we can indicate it here and here to make sure it's actually running true, not going like this.
Yeah.
And it's all about accuracy. Like I say, everyone's indicated. It's not, it's not cheap to have machines sitting there not running while you're indicating, but it's necessary for what we're trying to achieve. And most of the time he doesn't have to do anything. You know what I'm saying? They chuck up within a couple tenths, but you got to check it.
Yeah.
So.
And then is that when you cut the receiver threads?
Yeah. Yep. That's what I was talking about. That's all about receiver threads.
So OD and receiver threads, perfectly concentric, running completely true to each other.
Yep.
Okay. And then what's after this process?
So the next thing will happen is the tangs get cut.
Okay.
And that's back down there
over
on
to
the
the other
mill.
machine.
Yeah. Yeah. So back to the horizontal for the tang operation. Our fixture here cuts the tang, and on this particular model we're set up for right now, which I have in my hand, this does not have the integral Picatinny rail.
Yep.
But it does have the integral recoil load. So we'll also take that ring and machine it down.
Yep.
So get a little better view here of what's happening. So a blank goes in there, it's like that. There's locating dogs down inside that locate the raceways for orientation. And then as far as centering it, we probe it with machine's probe. It's kind of like a digital indicator.
Yeah.
And so probes it for sideways so we can get the slot dead center.
Gotcha.
And also probes length so we can get this dimension correct to the other end repeatedly with no stress. So Yeah.
And you've even got some engraving on here.
Yeah, you go ahead on the repeaters. We go ahead and engrave the safe and the fire on there at the same time. And then, as well, when this side is machined, probe goes in and probes for position there to make sure the lug is centered. Not that it really matters that much, but it looks terrible if it's off center.
Gotcha. So you got two different operations set up here. Pallet rolls in, both operations get cut.
Yep.
Gotcha.
That's it.
And
pretty
then
basic.
After this,
it goes to the last operation where the thing becomes a finished receiver. One other thing I was going to mention on this is our cam for our extraction happens on this as well. And this is a helical move so this is a 4-axis machine, and so that enables us to cut that as a true helix. Aids in the bolt smoothness opening when we're extracting tight cases.
So when you're machining the bolt, which we'll get to later,
it's the inverse with a matching helix.
Exactly.
That matches that exactly.
So those are going to slide together, extract the case from the chamber smoothly. Boom.
Yep.
Very nice.
Yeah.
Okay, so on to the final machining.
Yeah, let's do it.
So the last operations happen here. Tell us about this machine.
Yeah, so it's just a simple 3-axis machine with a rotary axis. And it's a full rotary, not just an indexing rotary. So you can program any increment you want. And all the machining to complete the receiver happens in this last operation. Ports, trigger pockets, scope base holes, in this case an integral rail, the engraving, all the holes threaded, everything. When it comes off of here, all it needs is deburred.
Gotcha.
It's ready to assemble.
And this part here is going to become a receiver body with an integral rail, is that correct?
Integral rail and integral lug.
And how long does that complete set of operations take?
Approximately 45 minutes.
Gotcha. Can I press the go button?
Of course.
Okay. Okay, so do I literally just hit the green button?
You just literally hit the green button.
Here we go. Are you guys ready? I'm gonna do my first CNC receiver here.
What do you think?
This is easier than running a manual machine.
What's he taking off of there? About 150 thou deep cuts. Cuts like butter, doesn't it?
Yeah, I heard a little bit more chatter sound on that first cut.
Down on the tailstock. And
gotcha.
Yeah, this is just roughing, getting rid of material.
Yeah.
And then it'll go back to finishing.
So that process took approximately 45, 47 minutes, somewhere in there, and we end up with this. For coming straight out of a CNC machine, that is a beauty. And this will get polished, but before we talk about that, why don't we go through the machining process, the full production process on the bolt, and then we'll go to polish.
Yeah, sure. That sounds like a good idea, yep. So here at Bat Machine, we make two different kinds of bolts. We make the modular style, and then we make a one-piece version now as well. The two-piece bolts, modular bolt, starts as a piece of 4140 hardened to 4145 Rockwell. Then it goes to the lathe and gets the initial turning done, lug diameter, bolt diameter, and then the key for the modular bolt gets machined. After that's done, that bolt body then goes down to the mill, gets the extractor, ejector, lugs milled, gas port, cross pins, flutes, gets all that done. That takes care of the bolt body. The handle side of that modular system starts as a 2.5 inch diameter piece of 4140, 32 Rockwell. This is part way through the roughing operations, and then finished, completely finished. Now this all happens, this piece is completely machined from here to here in one machine.
Wow.
Our Mazak Integrex. So it's a milling machine slash lathe.
Wow.
And allows us to keep the center line of all the different operations exactly on center.
And that's this machine?
That's
is that
this
right?
machine here, yeah.
So why don't we start here with the bolt handle and then we'll do the body second.
Sure, sounds good. So here we are at the Integrex, and here is a blank for a one-piece bolt. I know you were just talking about the modular, but this is what I'm set up for in this machine at the moment. We'll go ahead and load one of these and start it running. Now you won't be able to see anything anymore, but
so it's going to go through and cut the entire, a lot of material to take off.
Yeah, so that's hogging out this shape here, getting rid of that ring. And before it's all done, it'll have the holes machined in there and be cutting the extraction cam. Finishes the bore in here, cuts the cocking cam, and then this contour is cut a little bit under the bolt's diameter so it doesn't ever affect the alignment of the bolt itself.
Yeah.
So the two-piece modular bolt goes through basically the same operations, but it gets, after it's done with this stuff, it gets handed off to the chuck on the other end to finish the last operations.
Gotcha.
So from there, we need to go to the bolt milling.
So that's going to run for a while?
That's going to run for a while. Let's go look at the final operations.
Okay, sounds good. So here we are right across from the other shuttle machine. This is a pallet shuttle machine, is that correct?
Yeah, so that's kind of uses a rotary pallet system. This is a shuttle system, so it swaps like this instead of rotating. But so what we have here is we have a 4th and 5th axis on this table. So this allows us to clamp the bolt that would have just come from the machine down there, the Integrex, in here, and machine the locking lugs, and that to that, and then it does the extractor and ejector and all that business. After it's done with that operation, then it goes to the other pallet and machines the flutes and the gas port hole. So this rotary axis here allows you to, this tilts down here, and this rotates 360, so you can get to all kinds of different positions in one clamping. Again, kind of like I was talking about in the Integrex, so we keep everything in relationship to the same center line. So yeah, we can go take a look over there at the fluting operation.
Yeah, open the doors and see it from the side.
Yeah. So here we are in front of the machine. There's a bolt in there. This is what's going to happen to it. Right now it's ready to be fluted. So pallet's already been put in here. So really all we need to do is close the door and hit start. We'll hit start first to make it more exciting.
Yeah, see it a little bit better.
Actually, you know, we can open the doors on this. I forgot this is dry. So nothing real exciting. It's just another rotary axis, same machine, just on a different pallet.
Yeah. Side milling.
Yeah, it's a tool that we kind of adapted to cut flutes. Not really a standard one, but uses standard insert. And next pass, and you'll actually be able to see the groove it's cutting.
So back in the old days, you'd have to have a gearbox for your rotation.
Yeah, you'd have to have it all geared to...
Kind of like helical gear cutting
right.
equipment.
That should be the last pass. So now it's just going to drill the gas port hole. And that will use coolant.
Now what are we doing?
Gas port hole.
Okay.
So when you blow a primer, lets the gas out.
Yeah.
So that last little cut was this chamfer right here.
Yep.
On these two corners. And of course the gas port hole and the chamfer. And your flutes.
Very nice.
All right, let's go on to the deburring.
Yeah. So this is polishing room?
This is polishing. You got it. So we have the receiver that just came out of the machine. We have bolt that just came out of the machine. We have a receiver that's been through the first deburring operation, bolt through the first deburring operation, and then final shine. So what goes on in between those is the first operation, there's some handwork that happens inside of the receiver that the machine can't get to real well.
Yep.
So it takes a human to do that. And same thing on the bolt. There's a couple little things that they have to hand polish on these before it goes into the machine. If this action is going to be nitrided, it just goes directly from here to nitride. If it's being shipped as in the white, shiny stainless action, it goes to the next step of polish. This is more of a cutting media. It removes all the cutter marks. This takes that finish and shines her on up.
It's, aside from the handwork that's done to deburr edges, it's just really amazing to me that it preserves the engraving.
Yeah.
And it can apply such a nice finish without having to hand polish the whole thing. That's awesome.
Yeah, they're quite incredible machines, really. It takes a bit of experimentation to get the results you want, but once you got them dialed in, they work very, very well.
So we've got our receiver body finished at this point. Obviously, you have to send it out for nitriding if that's going to happen. We've got our finished bolt. It's just a matter of final assembly. And shipping at that point.
Yeah, exactly. So you want to go check out final assembly?
Yeah, let's do it.
Okay. Hey guys.
So here we are in assembly and shipping. Denny and Steve, thank you for letting us interrupt your workday. So Bruce, this is where it all comes together and it goes out the door. Tell us about this process.
Yeah, so Denny, he takes care of putting all the little parts together. So you guys watched the big parts being made, your bolt and the receiver. We didn't show you things like trigger brackets, recoil lugs on some models that are separate. Didn't show you a manufacturing of the bases, bolt stops. Denny assembles all those, checks them for function, as well as the bolt. The bolt needs all the cocking piece, firing pin, spring, lock screws, lubrication, the bolt itself, extractor, ejector, and then once he's got that all assembled, he checks it for function and makes sure it's good and smooth. And if you got any complaints, talk to him.
It's hard to believe that these major components started out as chunks of round bar.
Big blocks of steel.
And here they are, beautiful pieces of equipment, kind of jewelry almost.
Yeah.
That's the way I think of it.
Yeah. So, and so Steve, he takes care of the shipping, and if you're the guy, he's the guy that you need to talk to for getting your ATF, and usually actually placing your order. If you place an order direct with us, you'll be talking to Steve, sometimes Daryl, but and any accessories you need, you'll be talking to Steve.
Very cool.
Yeah.
It's been great hanging out. It's been great meeting the team, spending some time with you all. Really appreciate it, Bruce.
Yeah.
Hopefully I'll come back here soon.
Yeah, please do.
Well, I don't know about you all, but my mind has been officially blown. That was an absolutely amazing experience, taking the factory tour, really seeing behind the scenes what goes into building a top quality custom action. I know I'm inspired for my next rifle build. You're gonna wanna subscribe with notifications because I've got more rifle builds, more technical information that I've partnered with the team here at Bat Machine on. And here's what I'd like to know is, what do you think? What did you think of the factory tour? Do you shoot a rifle with a Bat action? Drop a comment and we'll start a discussion. If you liked the video, please give it a thumbs up. Don't forget, I got Ultimate Reloader shirts at the Ultimate Reloader store. I'm on Patreon. I got a full article with a lot more detail and description. Links in the video description. Thanks for watching. Until next time, happy shooting and happy reloading.